Hello everyone, and welcome to How-FixIT. If your DJI Mini 2 fell into water, does not power on, shows no signs of life, or started showing errors after drying, the problem may be caused by moisture, corrosion, or damaged components on the internal boards. In this video, I'll show you how to repair the DJI Mini 2 after water damage, inspect the boards for corrosion, clean the affected areas with distilled white vinegar, rinse them with distilled water, clean the boards and connectors with high-purity isopropyl alcohol, dry everything completely, restore the thermal interface material, and only then reassemble and test the drone. This guide is useful for drones that fell into fresh water, rain, snow, or salt water. But remember, if the drone was exposed to salt water, corrosion can start very quickly, so the sooner you open and clean it, the better the chance of recovery. For this repair, you will need a Phillips No. 1 screwdriver, tweezers, and plastic pry tools. For reassembly, you will need a hot glue gun. I've included links to the tools and replacement parts in the video description below. Before you start, remove the battery. Remove the two screws securing the bottom cover of the drone body, then use a plastic opening tool to carefully remove the bottom cover. Next, remove the three screws securing the heatsink to the main board. There is thermal paste between the heatsink and the main board. If the thermal paste is damaged, dried out, or dirty, it should be replaced during reassembly. Disconnect the two antenna cables from the main board. Now, you need to disconnect three cables from the board, but the connectors are also secured with adhesive. First, remove this adhesive carefully, then disconnect the cables. On the back of the main board, there is a black heat-dissipating adhesive sheet that helps hold the board in place. To remove the board, you can either peel this adhesive sheet away from the frame, or gently warm it with a hair dryer and carefully separate the main board from the adhesive. Now that you've reached the motherboard, let's move on to inspecting it for signs of oxidation. One of the first indicators that water has reached the motherboard is the moisture indicator sticker. This sticker is originally white, but if it comes into contact with water, it turns red. Your drone's motherboard may include various sensors, so I recommend removing them if possible to prevent accidental damage during cleaning. Additionally, all DJI boards are equipped with a shield plate which covers and protects critical components. Small metal tabs around its perimeter secure the shield. To remove it safely, use a plastic spatula or tweezers to gently pry from underneath. carefully working around the edges to release the tabs without bending the shield or damaging the board. Under the shield plate, you may find a thermal interface that helps transfer heat away from the components. Carefully lift it using a plastic spatula. You'll need it for reassembly. Moisture often seeps beneath the shield plate, so it's important to remove it and inspect the underlying components for any signs of corrosion. Now that you've exposed the board and have full access to all components, carefully inspect the motherboard for any signs of oxidation or corrosion. Look closely at connectors, solder joints, and ICs for discoloration, residue, or buildup that could indicate water damage. In some cases, especially if your drone fell into salt water, you might notice signs of corrosion on the motherboard, like green or white residue. These are oxidation products from metals like copper. Oxidation can cause permanent damage to electronic components if not addressed promptly. Next, I'll show you how to remove this type of corrosion from the board. If your drone fell into fresh water and the board does not yet show signs of salt or oxide deposits that need to be neutralized, you can skip the acid cleaning step and proceed directly to cleaning the board with isopropyl alcohol. To clean the board and remove corrosion, you will need distilled water, distilled white vinegar with 5% acetic acid by volume. It's very important to use only plain distilled white vinegar with no additives or flavorings. Avoid apple cider vinegar, wine vinegar, or any aromatic types, as they can leave sticky or conductive residues. And isopropyl alcohol, minimum 90%. However, I recommend 99% for more effective cleaning. To clean the motherboard, submerge the corroded area or the entire board in distilled white vinegar for 10 minutes. Vinegar is a mild acid that helps neutralize salts and dissolve corrosion. It's safe to use for electronics if applied correctly. After 10 minutes, take a brush, a soft bristled toothbrush will work, and gently scrub the corroded areas on the motherboard. Brush gently. Apply light, even pressure, no more than the weight of the brush itself. You're not trying to scrub the board clean with force. The vinegar is already softening the oxidation. Your job is just to help it break loose. If something isn't coming off easily, it's better to soak it a little longer and return than to force it. Once you've gone over all the oxidized areas, gently swirl the board in the vinegar to rinse off any loosened debris. After this step, we'll need to thoroughly rinse the board with distilled water to neutralize the vinegar. Never use tap water, it can leave behind even more mineral deposits. Keep in mind, vinegar is not a primary cleaning solution, but a backup option for severe corrosion that alcohol alone can't remove. And unless you follow up with proper rinsing and drying, vinegar can actually make things worse over time. So use it carefully and always as part of a full cleaning process. Use 99% isopropyl alcohol, or at least 90%. It displaces water and removes dirt and electrolyte residue from the contacts. Carefully apply alcohol to the board, or fully submerge the motherboard in isopropyl alcohol for the most effective cleaning. Then gently clean the surface with a soft anti-static brush or a soft bristled toothbrush. Even if your drone appears to function after drying, corrosion can develop weeks or even months later, so preventive cleaning is essential. Gently start brushing the surface of the board. Use light, controlled strokes, almost like you're painting a thin layer. Focus especially on the areas where you saw corrosion, typically near connectors, solder joints, or exposed contacts. Keep your strokes consistent. Move slowly and deliberately across the entire board, section by section. If you notice bubbling or cloudy residue lifting off, that's the oxidation being loosened, exactly what you want to see. Pay close attention to component legs and under connectors. Oxidation likes to hide there. As you go, you might see some white residue lifting. This is typical with water damage. Keep brushing until those spots clear. Remember, patience is key. Don't rush. It's better to go over an area multiple times lightly than risk damaging the board by being too aggressive. Once you're done cleaning, lightly wipe it with a paper towel to remove excess alcohol and let it dry completely. If the liquid has only reached certain areas of the board and you're confident that a full immersion isn't necessary, you can perform a localized cleaning. Just apply isopropyl alcohol directly to the affected components and gently scrub the area with a soft brush. Pay special attention to areas under the chips and inside the connectors. Also, clean the connectors that attach to the board, as they may contain trace minerals or contaminants that can lead to future oxidation. If your drone's motherboard was exposed to water and you cleaned it with both distilled water and isopropyl alcohol, it's important to allow extra drying time. In this case, moisture can remain trapped under chips, inside shields, or in tight gaps, and that can lead to corrosion or short circuits once power is restored. So if you used white vinegar and distilled water as part of the cleaning process, I recommend waiting 6 to 24 hours for complete drying. Place the board in a warm, dry, and ventilated area, ideally with light airflow or gentle heat at around 40 to 50 degrees Celsius. However, if you only cleaned the board using high-purity isopropyl alcohol, 90% or higher, and did not use water, the wait time can be much shorter. Isopropyl alcohol evaporates quickly and doesn't leave residue. In most cases, 30 to 60 minutes at room temperature is enough for safe reassembly. You can also gently speed up the process with airflow. Just make sure there's no visible moisture trapped under components, and never power the drone back on, unless you're completely sure the board is 100% dry. Spread the thermal paste evenly over the area where the component requiring cooling makes contact. DJI drones also use a thermal interface on the shield plate to dissipate heat from the board. If the original interface is no longer usable, it's recommended to replace it with a new one. Regular PC thermal paste is not suitable for drones. It's too soft and not designed for movement, which may cause it to shift or degrade under constant vibration. Instead, use a compound that is designed for environments with vibration, pressure variations, and uneven surfaces or gaps. Unlike thermal paste, thermal gel molds to the surface and fills microgaps without needing a perfectly flat surface. I've included a link to the thermal heatsink gel for DJI drones in the video description below. Now that you've finished with the motherboard, inspect the ESC board for any signs of corrosion and clean it if necessary. Also, clean all cables and connectors that attach to the motherboard using isopropyl alcohol. Once everything is clean and dry, reassemble the drone and try powering it on. Reconnect all cables and antennas to the main board, then use a glue gun to secure the connectors again with adhesive. Place the heatsink back onto the main board and secure it with the screws. Install the bottom cover and secure it with the 2 screws. Insert the battery and power on the drone. Watch the gimbal startup self-check, confirm that the camera image appears, and check the DJI Fly app for any required calibrations. Then perform a short controlled test flight in a safe open area. If you found this guide helpful, give us a thumbs up and subscribe for more tech tips and guides. Visit our website for more insights and do-it-yourself guides. Remember, every tech challenge is an opportunity to learn and grow. Thanks for watching How-FixIT, and we'll see you in the next one.